Hi, thank you so much for having me. I'm going to really quick turn on my webcam and hopefully that'll work well. You guys can all see me. Hope you guys are having a great morning. Today we are going to be talking about preventing concrete from ruining your next job. I think it's really important to start off though with, why is this a topic we care about? Why are we worried about moisture mitigation? Well, every year it is estimated that North America property owners spend over $2.4 billion addressing moisture-related flooring failures. That's a lot of money. But how much is 2.4 billion really? Well, to kind of give you guys a better idea of the magnitude of just how much 2.4 billion is, we're going to take a little history trip. So back in 1969, Apollo 11 landed on the moon. For reference, on average, this trip is about 238,000 miles from Earth. So 2.4 billion miles would basically mean over 5,000 trips to the moon. So with 2.4 billion miles, you could go to the moon and back over 5,000 times. That is a huge number. And when you put it into dollars, it is way more than anyone should be spending on moisture-related failures every single year. Okay? So a really quick agenda for today's talk. We're going to start off with concrete basics. We're then going to go into the effects of moisture, what types of moisture testing is currently on the market, moisture solutions, and then a short conclusion. So of course, we're going to start by just talking about concrete. Concrete is basically made out of four things. Cement. Cement is going to be your binding agent. It's going to be what keeps everything together. Then you've got your aggregate, which is a gravel typically or stone. That's going to provide strength and volume. Then you've got your additives. Additives can modify performance. It can be latex or other polymers, things like that to kind of help up the level of the concrete itself. And then finally, you've got water. Water activates the cement, but it also provides workability. So it's kind of twofold. You need water for the cement reaction to happen, but then you also need water to make it so that the product is workable. So for those of you that don't know, cement is considered a hydration reaction. That means that the cement and water react, they produce heat. Water is consumed as part of that reaction, and it's really, really important that you use the right amount of water to cement, right? When you compare that water to cement ratio, it is critical that it's the appropriate ratio. As concrete cures, I think many people know 28 days is kind of what we consider cured concrete. And the reason for that is over 90% of the strength is developed at that point. I don't know if you guys have ever looked at concrete strength curing graphs, but basically it's kind of an exponential curve that goes up very quickly to start with and then kind of starts to peter off a little bit. And you still continue to gain strength, but nowhere near as fast as in those first 28 days. Something else to be aware of course, is that concrete curing, it's a chemical reaction, and it can definitely be affected by your environmental conditions. The cure is going to be different if you're in, hot, humid Texas versus northern Wisconsin, right? So a really quick, nice, easy analogy for why water is so important, that, water to cement ratio is so important as part of this chemical reaction. I'm going to use a Kool Aid analogy. I hope most people have made Kool Aid or some type of similar drink. We all know that if you don't add enough water, you get a Kool Aid drink that is very, very strong, right? And it's the same with concrete. You end up with concrete that's tough to work with. It's not very, movable, not very flowable. But then on the flip side, you can also have too much water. And if you were to have Kool Aid, that means you're going to have a very weak tasting, kind of watery Kool Aid. Same thing with concrete. You add too much water, you can end up with very weak concrete. Now, within that, there is typically a range that, it doesn't have to be a specific perfect water to cement ratio. Typically, again, when you're mixing up Kool Aid or cement, there's kind of an area where, you can mix it to feel to a certain extent. And that's why typically there's kind of a water demand that's a range and not an exact number. So let's talk about moisture in concrete. A lot of times, as I kind of mentioned, water in concrete does two things. It allows the chemical reaction to happen, but then it also allows the concrete to be workable. Now, this extra water that allows concrete to be workable is called moisture of convenience. It's water that's not necessarily consumed in the reaction, but it's really necessary to be able to place the concrete where you want it. But the problem, of course, is that you've got excess moisture from this that needs to then be able to leave the concrete. That moisture has to go somewhere, right? And as you can see on this picture here, you've got a moisture vapor barrier that should be put underneath the concrete. That's that yellow kind of plasticky film underneath, which means that typically, if everything's properly installed, there's only one place for the moisture to go, and that is up. So that goes through kind of where moisture comes from in concrete, but let's talk about external sources of moisture, right? You can also have moisture in concrete from the groundwater, from high precipitation, from poor grading, other things like that, that can all add moisture into your concrete that could end up kind of flowing through to your finished floor covering. With that, it's also important to talk about liquid water, okay? Everything, that this presentation focuses on is about moisture vapor. And moisture vapor, believe it or not, is very different than liquid water. So liquid water is typically hydrostatic pressure. It's water that exerts a force on a concrete wall or, exerts a force on the floor of your, installation. I'm going to tell you that, unfortunately, I wish I could tell you I had a miracle product that fixes this. In the end, that's typically something that a professional engineer, a structural engineer, needs to be called in to remediate or to help figure out why you have liquid water moving through your slab. So what about moisture vapor? What about moisture vapor? Again, this is just moisture of convenience leaving the slab. Typically, that permanent moisture vapor barrier is beneath the slab, but then you can also use moisture mitigation products over the concrete in order to kind of reduce moisture levels that could get through to your flooring. So again, you should be able to see here, you've got some concrete that has that beautiful moisture vapor barrier underneath. They've definitely mixed it loose enough that they can install it and place it. There's definitely a little bit of moisture in this concrete that is not just needed for the chemical reaction. So here's the thing. What happens if your concrete moisture doesn't decrease enough before your finished floor covering is put over it? Well, unfortunately, you can end up with things that look like this. Disbonded patch, disbonded flooring. You can end up with bubbling. You can end up with tenting. You can end up with damage and in the end, kind of a job site that needs to be fixed before someone can continue using it. So kind of to summarize all those different things is bubbling, tenting, gapping in your flooring can occur. And that's because typically flooring traps all moisture underneath it, and that causes those bonding issues. So again, if you've got concrete with excess moisture and you put something like a sheet vinyl over it, it's possible that, that amount of moisture coming through can end up trapped underneath that vinyl. And it can definitely also damage things like hardwood. Additionally, it's not just vinyl that's affected by this. It can also be hardwood flooring as well. So one of the things that you kind of need to also be aware of when you're talking about the effects of moisture is how long you wait to get on the concrete. So a lot of times, we've got fast track installations. We don't have time to wait for it to cure out and for all of that moisture of convenience to leave because we need to get that job site moving, right? So it's good to keep in mind what product limitations you have and what products you're using because that's going to really affect how quickly you can get on that concrete without adding a moisture mitigation. So let's talk about kind of a checklist of what should you be doing to try and prevent moisture from causing a job site failure for you. The first thing is going to be plan ahead. And then also communicate with those that are running the job. Double check, what's going to be installed, when is it going to be installed, what types of concrete you're going over, and then also make sure you're communicating with the GC or whoever is in charge of the job what you need. And this is where a lot of times, having manufacturer representatives that or are in contact with can be really useful, right? A lot of times we can also kind of help you figure out what products would work for the conditions you're going in, what limitations they might have, and we can definitely help put together the literature that exists to make sure that you know what you're installing and you know what its limitations are. With that, you want to make sure you're recording important information like the slab thickness and its location. If there's a moisture vapor retarder, again, remember that kind of yellow covering underneath the slab. What if any curing compounds are used? That's really important, especially again now as things are getting more and more fast-tracked, having some idea, whether or not curing compounds were used. And the reason we care so much about that is a lot of times curing compounds can cause bonding issues with a lot of moisture mitigation or even finished flooring systems, right? So it's really critical to know what went on the concrete and whether or not it was removed, and if it was, how it was removed, I should say. Additionally, you want to make sure you're recording kind of what condition is the concrete in. Does it have a concrete surface profile? Is it flat? Does it look like, the hills? So these are all really important things to record. And additionally, it's also really important to check for things like relative humidity, your pH, and your ambient temperature. Okay. Once you have all of this information together, you can then start to really analyze what products you have and verify that they can be used in the job site conditions you have. And it's really important as you do this to make sure that you're not just looking at, oh, well, my adhesive goes up to 99% RH, so it's going to be fine. If the patch you're using doesn't go up to that high of a moisture level, if the vinyl you're using doesn't go up to that moisture level, you're going to have a bad time, okay? So remember, don't just look at one part of the equation, look at the entire system. And if the entire system doesn't meet the conditions that you have, that's when it's time to really make sure you're mitigating or you're taking steps to reduce the moisture that is going through to your flooring. Now, I know this is a lot to remember, a lot to think about. So what Tech actually did is we put together a moisture mitigation pre-installation checklist. This is just kind of the first page of it, but it's 3 pages long and just kind of has all the information, all of the questions that it's good to ask before you go in and start just installing flooring. So again, this is on our website. It kind of makes it a foolproof checklist to make sure that you've looked through everything and that you have all the things recorded, for the job site. So if you need to go back and check things later, you've got it all written down right there. So let's talk about how you're actually going to be testing these things, though. Again, the main thing we're going to talk about is going to be concrete moisture testing. I'm sure a lot of you guys are familiar with the RH meters, and this is tested per ASTM 2170. This is a quantitative test, and I love this test because it spits out a number, right? It gives you a number, a percent of the RH, or the relative humidity of the slab. It also measures about 40% of the thickness of the slab, or about 20% if you're drying from 2 sides. So you really get a good idea of what's going on throughout the entire slab, not just what's going on right at the surface, okay? The other thing, this is a great product, or the other reason this particular test method is a really great way to go, is that it's not highly sensitive to ambient conditions. So if it rained the night before, if it's a little bit hotter, if it's a little bit cooler, if it, is a humid environment, it's not going to be as affected by those types of conditions. The other thing, as I mentioned earlier, it gives you an electronic reading. It gives you a beautiful number that comes out that you're not having to guess what it is. I know they have ones now that even have Bluetooth. You can pull it up on your phone. This one that I've got a picture of here is kind of one of the originals that, when you put that probe in, you can actually see, the number on that, kind of a little digital display. One thing I do want to note is that it's not enough to just do one probe test for the entire job. And this is where I can see people making a lot of mistakes, right? Is they do one test for a 10,000 square foot job, and unfortunately, that's just not enough to understand what's going on in the slab. So I kind of give an example slab right here. Let's just kind of pretend this is, your average job. If you have to meet the standard and perform 3 tests in the first 1,000 square feet and another test every 1,000 square feet after this, how many tests or how many areas do you guys think is going to be in this, 100 square foot by, almost 50 square foot job? Well, you're going to have an area here, and you're going to have another 3 areas here. So if you can imagine, these little orange dots are probes, you're going to need 3 tests in your first section and then 1 test every section after this. And this is really critical because if you have a slab that, maybe there's something going on in one area that you don't get in the other, and it could be something as silly as a pipe burst, or you've got poor grading to that area. The only way you'll be able to pick up on, situations like that that are only affecting one area is if you continuously test those multiple areas. So it's really important not to just throw one probe in and call it a day. You want to make sure that you are testing throughout the job. And again, double checking that if you have issues or if you have, moisture that's at, let's say, 80% in all areas but one, which goes up to 100%, that you start to question, why is that area that much higher in humidity? And is there something that's going on that's not just, regular moisture of convenience leaving your concrete slab? So let's talk about another concrete moisture test, ASTM F1869. This is most commonly referred to as the calcium chloride test, right? This is going to be a quantitative test that determines the moisture vapor emissions, or MVER, coming out of the top of the slab. This is definitely a tried and true. It's a more traditional method of measuring moisture, but it's important to note that it only reflects the condition of the concrete at the time of the test. That means that HVAC systems turning on and off, ambient humidity, job site conditions, all can affect this test. Additionally, and this is for those of you guys that have never seen a calcium chloride test, this is what it looks like. You basically have a little dish of calcium chloride that is put underneath a special piece of plastic that is then sealed down. This particular test only reflects moisture in the top kind of 3/4 of an inch of the slab, and it doesn't address moisture issues throughout the entire slab, okay? So again, it's definitely a little bit different test. The other thing I'm going to add with this one is the way that it works, again, is you put that little dish down and you actually weigh it. You get the mass of the dish before and after the test, which lasts 3 days, okay? What you then do is a little bit of a conversion to understand, how much does the weight gain of that calcium chloride dish correlate to the amount of moisture that's coming out of the slab, okay? So again, it's really important to notice this particular test requires you to take 3 days to let the test run before you can actually mass it and get an MVER. Something that I want to make note of here too is you've got a calcium chloride test and then the RH test that we talked about. I wish I could tell you that there was a correlation, a magical formula we could put into, the relative humidity versus the MVER, and we could, transfer MVER into the equivalent relative humidity. Unfortunately, there's nothing like that exists. It's not like, Fahrenheit to Celsius, where just an easy, formula kind of does that conversion. It doesn't work that way. So if you take a moisture reading in MVER, you then need to pull up product information that has that MVER. Same thing for %RH. Just kind of a quick comparison, to MVER is going to measure the top 3/4 of an inch of your slab, where RH can really get a much better reading throughout the slab. The MVER readings are also greatly affected by environmental conditions, where the %RH is not. So again, just kind of things to keep in mind as you're trying to decide what test method works best for you. Okay, so let's talk about moisture solutions, okay? Now, the quote I like to use when it comes to moisture vapor barriers is a Benjamin Franklin quote that says, "An ounce of prevention is worth a pound of cure." It is a heck of a lot easier to prevent a moisture issue by just taking a little bit of time before the installation than it is to try and fix the issue after the fact. Additionally, there's nothing that sucks more than having to go back and redo a job that you already did because there was a moisture issue, right? Nobody wants to do a job twice. It's no fun. And in addition to the fact that it's very expensive, right? So with that, let's kind of start with different solutions. Well, again, if you've got liquid water, you can definitely do some initial checks of the job site. See, is there anything obvious that could be causing liquid water in the job, okay? This is actually from a job where we had a complaint of moisture coming through the slab. And what we noticed was that they actually had installed a brand new sprinkler system 2 weeks before we were there, and it was positioned right up next to the building. And that sprinkler system actually would spray water directly onto that concrete wall, and it was amazing. Just that section underneath those sprinklers had issues, nowhere else. So the point of this is if you can kind of figure out, are there any obvious causes of liquid water coming in? You know, is it a burst pipe? Is it poor grading, sprinklers, things like that? That might be something that we can, you can offer and troubleshoot a fix for. If you can't find anything obvious like that, it's time to contact a structural engineer to figure out what's causing that. The reason that I really kind of talk a little bit separately about liquid water versus moisture is they're two very different things. So remember, this presentation focuses mostly on solutions for moisture vapor, not liquid water. So let's talk about moisture vapor solutions. The first thing is you're going to do what I had kind of mentioned before, which is you're going to analyze the slab using those test methods, determine whether further action is required, okay? And then you're going to think about your product limitations. And remember, not product limitations of just the adhesive or of just the vinyl, but of the entire system as a whole, from the self-leveler or patch to the adhesive to the vinyl itself. Everything needs to be okay in the conditions you're installing it in, okay? Now we're going to talk for a second more about liquid water versus moisture vapor. And this is something that we get a lot of questions about, and I think it's a very misunderstood topic, okay? A lot of times people don't understand how to differentiate between a waterproofing membrane and a moisture vapor barrier, and they try to use them interchangeably. So for those of you guys that don't know the difference, basically you're talking about moisture versus liquid, okay? And the other thing is you want to think about where that moisture, that liquid is coming from, okay? If you have true moisture vapor, extra moisture of convenience coming through the concrete, that's typically going to be moisture vapor emissions, right? It's not liquid water. It is just, the humidity, the moisture in the concrete itself. On the other side, you could have positive water pressure. Typically, that's not coming from your concrete slab. Where we normally see positive water pressure is going to be in shower installations, right? So if you've got water coming from above, it's going to then land on the membrane so that it can't get through to the substrate. It's typically going to be liquid water, and it's not going to be substrate moisture, okay? So you can kind of see in this image I've got of the shower, you would typically have, again, shower where there's actual liquid water coming out, and it would land on that membrane, which is protecting the substrate, be it concrete or again, a shower mud bed, whatever you're installing, from the actual liquid water that's coming through. So it's really important not to use these types of products interchangeably, okay? Additionally, let's talk about vapor permeability. So when you specifically talk about moisture vapor, we typically talk about it in perms. Perms is basically just a measure of how much moisture goes through the concrete slab, okay? So when you talk about moisture vapor, perms, the lower the number, typically the better. So if you have a true moisture vapor barrier, it's not going to allow more than 0.1 perms through. So that looks like that, right? Not a lot of moisture going through. But you can also have things like moisture vapor retarders. They can slow down the movement of moisture, but they don't really stop it, okay? So it's really important to know the difference and make sure that you know what you're purchasing. Is it a moisture vapor barrier or is it a moisture vapor retarder, okay? And kind of the magical number is 0.1, okay? So if it's less than 0.1 perms allowed through, you're talking about a true moisture vapor barrier. If it allows more than 0.1 perms through, that's where you're talking more a moisture vapor retarder. Now, when you're choosing that moisture mitigation system, you need to make sure that you know whether you're buying that moisture vapor barrier or just a moisture vapor retarder, okay? And you know what? There's nothing wrong with moisture vapor retarders, but it's important to know what you're purchasing. And it's important to, again, make sure that the entire system is okay with the moisture levels that moisture vapor retarder can give you. Again, if that moisture vapor retarder can bring the moisture down to anything below 90%, that's great. But if your vinyl or if your adhesive only goes to 80% RH, again, you're going to have a bad time. So really critical to know kind of the two different things you're dealing with and make sure you know what you're purchasing. So now let's talk about the different moisture mitigation technologies. There's kind of two big ones in this category. You've got your traditional epoxy. It's going to be a two-part system that's mixed on site, okay? And if any of you guys have ever worked with epoxy, you know that you have to mix the whole kit and you have to use the whole kit. Even if you've only got 5 square feet left that need moisture mitigation, you have to go through the whole kit. Additionally, anyone that's worked with epoxy knows that you can develop an epoxy chemical sensitivity, okay? So you want to make sure that you're handling it safely, that you're wearing the proper PPE, that your employees are wearing the proper PPE to make sure that they don't develop this chemical sensitivity. Additionally, it's going to have to be properly disposed of. You can't just mix up a full bucket of epoxy and then leave it, right? Because what happens is as that epoxy reaction starts to kick off, it kicks off a lot of heat. And a lot of times if you just leave it concentrated in a bucket, again, a large system of, mixed up epoxy, you could end up with so much heat, the bucket could start smoking, and you could actually overheat that area. So it's really important that once it's mixed up, it's properly disposed of. We typically will recommend to people that you mix it with, a large amount of silica sand to kind of act as a heat sink, or the other option is to open up kind of the cardboard box that our epoxy kits come in and spread it out so that that heat can kind of dissipate from a larger area. The other thing I want to talk about with traditional epoxies is it meets the ASTM F3010. So F3010 is the ASTM standard that basically says this is what a moisture mitigation system is. And it actually specifically states that it must be an epoxy system and that it must have less than 0.1 perms allowed through it. And so that's the standard that most of these moisture mitigation systems are going to be judged on, okay? There are other technologies out there though. We have, for example, a one-component water-based product. The really nice thing with the water-based products is it's one part. You don't need to mix it. You don't need to do anything special. If you have leftover material, you just put the lid on it and you take it to the next job site. Water-based for ease of use, which means that, when it comes to the chemical sensitivities we talked about with epoxies, much, much, much less likely to have a reaction. And basically, if you do get it on your skin, it's as easy as washing off with soap and water. Unfortunately, though, the way that the ASTM standard works is the ASTM 3010 specifically calls out it must be an epoxy system. So all of the one component water-based systems technically will not be able to meet 3010, even if it meets all the performance characteristics. Because it's not an epoxy, technically you can't state that it meets the entire specification, okay? I'm gonna get a little bit product specific now, and we're gonna talk about the moisture mitigation lineup that we have. Our product is called LiquidamEZ and LiquidamEZ. So LiquidamEZ is going to be our traditional epoxy system, and then LiquidamEZ is going to be our next generation system, that water-based, a little bit more environmentally friendly, a little bit more, installation friendly product. So LiquidamEZ epoxy, that's going to be a moisture mitigation, right? This is going to meet the less than 0.1 perm ASTM F3010. It means that you can apply it all the way up to 100% RH. You can cure it in about 4 to 5 hours and have same-day flooring installation, and you can install it on new or existing concrete. We don't actually require a specific concrete surface profile or anything like that. Typically, you can go over, green concrete very quickly. So kind of some features and benefits with that. I will say, though, it does require priming. So anytime you've got an epoxy, right, it's going to have a very, very almost glossy sheen. And you can see in this picture here, right on the bottom edge, kind of an area where you've got a nice sheen. And that's kind of where the flooring hasn't been primed. So when you use an epoxy, it's really important that you can't just install epoxy and then go. You're going to need to install a primer or something over it so that you can then pour, again, self-leveler or patch on top of it, okay? So then we also have our LiquidamEZ. Again, this is going to be the single component moisture mitigation system. It's, again, water-based. The nice thing, though, is that except for the fact that it's not an epoxy, it actually does meet the performance characteristics for 3010. So it'll go all the way up to 100% RH, and it does give you a less than 0.1 perm barrier. Additionally, you can use it on green concrete after 48 hours, and you're going to have a same-day flooring installation. The other nice kind of easy thing with this is going to be that it's put on in a 2-coat application, but that second coat acts as a primer. So anyone, if you're shipping things out to larger commercial jobs, it means that you're shipping out one product that's going to be your moisture mitigation and primer. You don't have to send a moisture mitigation and a primer, okay? So again, this one's going to be what's considered a true moisture vapor barrier that basically meets the ASTM 3010 perm rating. Again, because it's not an epoxy, technically it's not, ASTM 3010 rated, but it does meet the performance characteristics of 3010. You can apply this over 2-day-old concrete, again, all the way up to 100% RH. And you might not need to shot blast, right? You might be able to, provided it's clean, sound concrete, you might be able to just go directly over the concrete as is. Additionally, you've got kind of some worker safety benefits with this product. You're not dealing with the potential for chemical sensitization that you deal with epoxy. A lot more user-friendly. Additionally, because again, it's one product, it doesn't require priming, you could cut your labor costs. There's no mixing, no pot life, no waste, and no priming required. And you can still get same-day flooring installation. Typically, again, this is a 2-coat application. Your dry time is about 90 minutes. And with 2 coats, that gets you installing your flooring in about 3 to 4 hours. So again, same-day flooring installation, and it's just going to be one product that acts as both your moisture mitigation and your primer. So just kind of a quick recap. You've got kind of 2 different options in the tech lineup, at least when it comes to moisture mitigation. You've got both your traditional epoxy and then also your next generation, that water-based product that's a little bit more user-friendly, environmentally friendly water-based product. So in conclusion, it's really important to kind of take preventative measures to know your slab, understand your product limitations, and plan ahead. Don't be part of the $2.4 billion in moisture-related failures every year, okay? Take some of these preventative steps, perform some of these tests, talk with your technical reps, talk with your sales reps of the products that you're using, make sure that they're gonna be successful in the installation that you're putting them in, okay? And with that, if we do have any questions, we'll kind of start the question section now. And if you've got questions about a specific job, feel free to reach out to me after this webinar, and we can set up a time to discuss, again, some specific job site questions.
Thank you, Heather. There are a number of questions that people have submitted, so I'm going to read those out, and then Heather will answer them. One gentleman asked, specific question was, a fan on patch to help drying, is that helpful?
So you might think it is, but a lot of times what that actually does is it removes moisture that's needed from the patch. So again, we talk about there's a certain amount of water you need for concrete to react. And it's the exact same with any of the patch or the self-leveling products, right? So if you install a patch that you've mixed with water and then you put a fan on it, what that fan does is it removes the water that you put in it. And while it might seem like it dries faster, what you're going to end up with is underwatered patch, which is typically a lot weaker and it doesn't have the same integrity that a patch that was allowed to dry normally does. There are very few products that we will ever suggest putting a fan on. And typically if we do, it's indirect. But again, especially patch, any of the concrete products, typically a fan's not the best way to cure it.
Okay, another question is, site conditions often do not allow for RH testing to be completed under a controlled environment. How does that affect the results?
Could you repeat I missed the first couple words on that one.
Site conditions often do not allow for RH testing to be completed under a controlled environment. How does that affect the results?
Yeah, so that's especially true when you're talking with MVER. Again, those calcium chloride tests. One of the reasons we've really leaned towards and really started recommending installers start using the RH meters or the RH probes is that I don't think that there's a calcium chloride test that actually gets left undisturbed for the 3 days that it needs to get an accurate reading. So to that point, RH meters typically are a little bit better about not getting disturbed and not, again, having issues with site conditions. And again, they're not normally as affected by the, ambient conditions. I will say that is one of the reasons why we recommend multiple tests, just in case something does happen in one of the, test locations, you don't, base all of your assumptions based off of a test that might or might not be accurate based on the site conditions.
Another question is, what is the recommended treatment for dormant cracks and saw cuts below a mitigation barrier?
Yeah, so that is a fantastic question. So there's kind of two parts of the different types of cracks that you want to be aware of. First off, there's a difference between dormant cracks, which I believe is what you're asking about, and expansion joints. So make sure that you kind of know, is there any movement happening with the joint? If there is, it of course needs to be honored throughout the entire installation. For the expansion joints, at least, typically what we'll recommend is that you basically make sure you coat the entire interior of the expansion joint and then fill it with backer rod. And then when you pour your self-leveler or when you put patch over it, you honor that expansion joint throughout the entire installation. And what you were asking about, I believe, which is the dormant cracks, typically what we're looking for is whether or not it's moving and how large it is, right? So if you've got a really small kind of narrow crack, you want to make sure you remove any dirt, any debris, anything like that from there, because those can cause bonding issues specifically on those saw cut joints and cracks. What you'll then do is kind of use a paintbrush or something similar to kind of coat the entire side of that crack and kind of bridge it. For larger cracks, typically over about 1 millimeter, what we'll actually recommend with our Liquidam epoxy is that you mix it with a silica sand at a 1-to-1 ratio to almost form a slurry. And that silica sand helps you bridge the gap between those two sections of concrete where that crack is, right? Because the trick, of course, especially with epoxy, is it can be very loose. And you want to make sure that the epoxy actually spans the crack and doesn't just kind of fall in and leave gaps underneath. So again, it's going to depend on the size of the crack and whether or not it's actually a true saw cut joint that's not moving or an expansion joint. But typically that's kind of the way that we would suggest you handle it.
We've got a lot of great questions. The next question is, soluble salts are a known issue for epoxy mitigation systems. How do you suggest we best determine if they are present?
That is a great question. So a lot of times, it goes back to whether or not you can visually see latents, on the surface of the concrete. Sometimes you can have luck with like pH tests and things like that on the surface. And this is where, again, inspecting the entire job can become really critical because all of those soluble salts that you're talking about are considered bond breakers. The one thing I will say is that we don't ever recommend acid etching to remove it. Anytime that you go in with any type of acid, a lot of times you're going to have a really hard time removing it, and that can start to eat away at the products that are installed after the fact. So again, typically, inspecting it, noticing if it's there, and then making sure you're not using an acid to remove it.
Next question, which system is more cost effective? Which system is more cost effective, the epoxy or one component?
That is a great question. So, of course, pricing is going to, I don't typically get into that. But what I can tell you is typically you're going to find they're going to be pretty similarly or competitively priced on a square foot basis. Okay. Again, it's really difficult because they're not always a perfect apples to apples comparison. We sell our water-based moisture mitigation system in a 5-gallon, and I think we sell a 2-gallon kit for the epoxy, and the coverages are going to be a little bit different between those two. But when you look at a per square foot basis, the epoxy is going to need you to install the epoxy, and then you're also going to need to purchase primer to go over it. And then the moisture mitigation system is just going to be a 2-coat of the same water-based system. And again, typically when you take all that into account plus the labor, it comes out very, very close, if not oftentimes being a little bit cheaper on the water-based side. But again, I mean, if you've got specific questions about pricing and stuff like that, my email address is there and I can put you in contact with the right, sales rep to answer those for you.
Another question, I have moisture damaged repair on engineered wood floor. Water from outside was repaired. So should I use before the reinstallation after concrete has dried?
Yeah, I think maybe what you're trying to say is that there was an issue with, liquid water ending up, again, maybe there was a drainage issue or something like that, you ended up with actual liquid water coming through and ruining an engineered hardwood floor system. the cause of the liquid water, it sounds like, was removed, and now you're going in for a reinstallation. This is really going to depend on what type of, how high the moisture is and how quickly you're going into your installation, right? So if you take a moisture reading and it is particularly high, it would probably be a good idea to go in with moisture mitigation. If the concrete has had a chance to dry out enough and you're confident that there aren't going to be any additional moisture issues, it might not be necessary, but it's really going to depend on kind of what your moisture levels are and whether or not you have time to wait for things to dry out.
Thank you for participating in today's webinar. Feel free to contact me at heather.ruhl, R-U-H-L, @hbfuller.com if you have any questions.